Hello everyone, today we are going to share with you some of the most important ideas we have discovered in the area of alternative airspeed measurement. Some parts of the video were filmed in the International Airport Plateau. We would like to thank the administration of the airport and the airline Azimuth for cooperation. Please enjoy!
As you know, airspeed is the speed of the plane relative to the air. On modern aircraft, indicated airspeed is measured by pitot tubes and static ports. Pitot tubes measures a so-called total pressure and static port measures static pressure. The difference between the total and static pressure is the dynamic pressure. It only depends on how fast an aircraft body travels through the air. So that way dynamic pressure defines the airspeed. True airspeed, which is used by the crew for aircraft navigation, is distinguished from the indicated airspeed used for piloting. Indicated airspeed is calculated by constant density and characterizes the airflow. This parameter is one of the most important in flight because it does not depend on altitude and unequivocally sets the quantity of lift generated by the wings. That is so essential for the flight.
Unfortunately, in the history of civil aviation, there are many examples of aircraft accidents caused by blocked pitot tube, in particular because of the tube's icing. For example, a major accident occurred on February 6, 1996. Virgin Airlines Boeing 757 crashed into the Atlantic Ocean 5 minutes after takeoff. All 189 people on board were killed. According to the report, the cause of the disaster was a clogged pitot tube, in which there was a nest of a sand wasp. As a result of this, the crew undertook incorrect actions, did not understand the inconsistent readings of the airspeed indicators, and allowed the aircraft to stall due to putting it in supercritical angles of attack at low speed. Another event, the Antonov 148 crash in Moscow region, an accident that occurred on February 11, 2018. 71 people were on board the aircraft, all of them died. As shown by the initial analysis of the parameters of the recorder, the cause of the disaster could be misleading crew incorrect readings of the airspeed of the aircraft from icy pitot tubes because its heating was off. Besides these terrible accidents, there are dozens of others with a similar cause. In all the described incidents, the blockage of the pitot tube and, as a result, the lack of correct readings of the indicated airspeed led the flight crew into complete confusion. Because of this, the pilots undertook wrong actions that had led to air crashes.
So, what to do if data from the pitot tube is not available? How to read the airspeed? Obviously, there is a huge need to introduce an alternative method of measuring, calculating and indicating airspeed in case of lack of correct data from the pitot tube for various reasons, in order to prevent the recurrence of these terrible events. Modern aircraft are equipped with a wide variety of instruments that help pilots determine various flight parameters. Air data computer is designed to determine the altitude-speed parameters of the flight, angle of attack, airspeed, altitude, static pressure, and outside air temperature. In our method, due to the lack of data of the total pressure, we will use only data of the outside air temperature and static pressure. Together with GPS satellite receivers, the inertial navigation system can provide accurate data on the ground speed of the aircraft and its track. And with the help of weather radar, pilots may know the data about the wind, its current speed and direction. Thus, all the quantities used for calculations by the alternative method are in no way dependent on the total pressure measured by the pitot tube.
For your better understanding, we will skip some theory, let alone the calculations and formulas. We'll dwell on presenting our research in the layman's terms. The only thing you need to know is that in the final formula we only use parameters that are absolutely independent of the total pressure and therefore can be calculated without data from the pitot tube. This formula can be used in the calculation algorithm of digital instrument navigation equipment, and the obtained speed value will be indicated on the primary flight display.
Special attention should be paid to indication of the airspeed calculated using the proposed method. Let's consider it on the example of the instruments of Sukhoi Superjet 100. On the primary flight display, we may see the indicated airspeed measured by a conventional method. On the multifunctional display, we see the ground speed and the true airspeed. Alongside with them, the speed calculated by an alternative method can be indicated over here. We offer to call it calculated indicated airspeed. This term is not in use yet to indicate speeds.
Advantages of the new method for measuring indicated airspeed are almost no implementation costs, uses equipment that is already on board most airliners, provides sufficient measurement accuracy, guarantees to provide pilots with information about the indicated airspeed in case of emergency, which means it will not allow them to lose understanding of the position of the aircraft and the trend in case of failure or blockage of the pitot tube. If in the above stated accidents the flight crew had the opportunity to know the indicated airspeed of the aircraft, then with a high degree of probability this accident would not have happened. The developed method aims to prevent further accidents and human casualties that may occur due to blockage of pitot tubes of the aircraft.
We hope you've enjoyed the time we spent together. If any questions came up while you were watching, you may refer to our detailed report, presentation, or just contact us via this email. Thank you for your attention.